we're going to look at how we can divide polynomials. And for this class, we're specifically going to look at how we can divide a polynomial by a monomial. So to do this, we're going to remind ourselves of what we did in our last chapter with all the exponent rules. We have the quotient power. That is when we have the same base, and that is key. It has to have the same base. If they have the same base, we can subtract the exponents. If they don't have the same base, can't subtract the exponents, but if they're regular numbers, we can just divide like normal. So here's an example here. That 12 and the 3, those are not the same bases. One base is 12, one base is 3. So we can't subtract the exponents. So we just divide like normal. 12 divided by 3 is 4. But with the x's, those are the same base. A base of x, a base of x, we're dividing, so we can subtract the exponents. 5 minus 2, and that's where the 3 comes from. So that's the process we're going to use to help us divide these polynomials. So like number 1. So again, find the quotient, we're dividing. So quotient just means you're going to divide. When we have this addition problem like this, or subtraction like in number 2, we are just going to divide each term separately by that denominator. So I'm going to write it out separately like that. I'm going to take the first term, the 12x to the 8th, and that's going to get divided by that denominator of 3x squared. And I'm going to drop down that plus sign. And then I'm going to take the second term, 18x to the 5th, and that's also going to get divided by the denominator. So each term in the numerator gets divided by that denominator. And then once we have this separated, we're just going to do like we did up here and do that division. So 12 divided by 3, again, those are not like bases, so we just divide like normal. That's 4. The x's are like bases, so I can subtract those exponents. 8 minus 2 is 6, so x to the 6th. Don't forget the x there. It's x to the 6th, not 4 to the 6th. And then drop that plus sign. 18 and 3, not like bases, so we can't subtract their exponents. Instead, we divide like normal. 18 divided by 3 is 6. And then the x's are like bases, so subtract the exponents. 5 minus 2, and that is 3. And then we want to make sure that we have no like terms, and it's in standard form. So biggest exponent, and then exponents get smaller. Same thing for number 2, so I'm going to take each term in the numerator and then divide that by the denominator. I have minus, and the second term gets also divided by that denominator. And then 15 and 5, we just divide like normal because they're not like bases, that is 3. X is like bases, we can subtract those exponents. 7 minus 4 is 3, so x to the 3 minus. 5 and 5 are like bases, so I could subtract the exponents, which are 1s, and 1 minus 1 is 0, so it'd be 5 to the 0, but anything to the 0 is just 1. Or I could divide them like normal. 5 divided by 5 is 1, so either way works in that case. And then subtract with our x's, they're the same base, so 5 minus 4 is 1. I could just put x, or I could put x to the first. It doesn't make a difference with the 1 there. So you could have this answer, or you could have 3x to the third minus x, because this one is optional to write, and that one is optional to write. Okay, number 3. So we have 3 terms in the numerator. Again, we're just going to divide each of those by the denominator. So I'm going to set this up. First term divided by the denominator. I'm going to bring down that minus sign. Second term divided by the denominator, bring down that plus sign, and last term divided by that denominator. And then we're just going to follow that step for each one of these. So the number in front, most of the time, is not going to have the same base, so we just divide like normal. 12 divided by 3 is 4. The x's are the same base. There's a hidden 1. Don't forget the 1. So 9 minus 1 is x to the 8th minus 30 divided by 3, because they're not like bases, we divide, and that's 10. There's another hidden 1. I'm just going to put the 1 on all of these. 7 minus 1 is x to the 6th. Bring down the plus. 21 divided by 3 is 7. 6 minus 1 is x to the 5th. And all my exponents should be different, so there's no like terms. And the exponents are in decreasing order, so 8, 6, 5. Okay, then we get into one like number 4. We're going to do the same thing. We're going to take each of the numerators and divide by that denominator. So we'll get that set up. So we take the first term, make sure we have every part of it, and that gets divided by the denominator. And then I'm going to show that hidden 1 on the z right now so I don't forget about it. Bring down the minus sign, and then that second term. Again, there's another hidden 1 on this z, and that gets divided by the denominator. And there's a hidden 1 on this z. Then I'm going to go ahead and do that dividing. So 26 divided by 13, not like basis, so we divide like normal. That's 2. The x's are like basis. 8 minus 2 is 6. The y's are like basis. 5 minus 3 is 2. And the z's are like bases. 3 minus 1 is 2. I'm going to bring down the minus sign. So just like the 5's we had up above here, these are like bases, 13, so I could subtract the exponents. 1 minus 1 is 0, but 13 to the 0 is just 1. Or we could just do 13 divided by 13 is 1. Either way works. With the x's, those are like bases, so we subtract their exponents. 5 minus 2 is x to the 3. The y's are like bases, so we do 4 minus 3 is 1. I could leave it as y, or I can put y to the first power. Either way is fine. And then z, 1 minus 1 is 0, but anything to the 0 is just 1. I can say times 1 here, but if I times it by 1, timing by 1 is not going to change anything, so we actually don't need that there. Instead, what happens when we have things like that, we can just kind of say they just cancel out. Kind of like 13s, and they're going to turn into 1. When they're matching exactly, they just turn into a 1. Okay. Number 5, same thing again. So each numerator gets divided by that denominator. Bring down the minus sign there. And then bring down the plus sign here. And then I'm going to go ahead and I have hidden 1s on all these y's, so don't forget about them. 18 divided by 9 is 2. For the x's, we subtract the exponent. 7 minus 4 is 3. For the y's, like bases, we subtract the exponents. 5 minus 1 is 4. Bring down the minus sign. 9 divided by 9 is 1, or, again, because they're like bases, we could subtract the exponents. 1 minus 1 is 0. 9 to the 0 is still 1. And then x's are like bases. 5 minus 4 is 1. I don't have to write the 1, but I could write the 1. And then for the y's, 4 minus 1 is 3. And the last one, bring down that plus sign. 54 divided by 9 is 6. And then for the x's, 4 minus 4 is 0. Anything to the 0 is just 1, so really that's times 1. But 6 times 1 is just 6, so then I'll just combine that and say that's just 6. And then for the y's, 3 minus 1 is 2. And then for our last one, each numerator again divided by the denominator, minus sign. I'm always getting the signs from wherever this is here. And then we have 2x to the 5th, y again divided by that denominator. And then we have some hidden 1s here and here and here, so we don't want to forget those. This one doesn't have that coefficient in front. The coefficient are the numbers in front. So we're just going to do our exponent rules on the variables. So x and x, we subtract the exponents. 12 minus 3 is 9. And on the y's, 8 minus 1 is 7. Bring down the minus sign. So this one we do have a coefficient on top, but there isn't one on the bottom. Well, technically there is. If there's no coefficient, it's a hidden 1. So really I have 2 divided by 1, which is just 2. And then the x's, we can subtract the exponents. 5 minus 3 is 2. And with the y's, 1 minus 1 is 0, but y to the 0 is just 1, so really that's times 1. But again, if I times by 1, it's not going to change anything, so we can just get rid of that.